Right now, as you watch this video, there is a star that could explode at literally any moment. When it does, it will become as bright as the North Star appearing in our sky, like a brand new celestial object that was never there before. And here is the crazy part. Astronomers have been watching it dim and brighten, following the exact same pattern it showed 80 years ago, just before its last explosion. The star is called T Coronae Borealis, also known as the Blaze Star, and we are living through a once-in-a-lifetime cosmic event. But this is not the only star preparing to blow. I am going to show you the most spectacular stellar explosions waiting to happen and reveal which one could light up our skies in 2026. Imagine being able to predict when a star will explode. For most stars, that is impossible. Supernova explosions happen without warning across cosmic distances so vast that by the time we see the light, the star has already been dead for thousands or even millions of years. But T Coronae Borealis is different. This is a recurrent nova, a star system that explodes over and over again in predictable cycles. And right now, in early 2026, we are in the window where it could go off at any second. Astronomers originally predicted it would explode by September 2024. That deadline came and went. Then researchers predicted March 27, 2025. Nothing happened. Then November 10, 2025. Still nothing. But here is what makes this so exciting. We know it is coming. The star has been following the exact same behavioral pattern it showed before its last eruption in 1946. It dimmed significantly starting in March 2023, staying faint for about a year. That dimming is the telltale sign that an explosion is imminent. The question is not if the Blaze Star will explode. The question is when. And when it does, astronomers and amateur stargazers around the world will witness one of the most spectacular shows the universe can offer. So what exactly is T Coronae Borealis, and why does it keep exploding? The Blaze Star is not actually a single star. It is a binary system located about 3,000 light-years away in the constellation Coronae Borealis, the Northern Crown. This system consists of two stars locked in a deadly gravitational dance, a white dwarf and a red giant. The white dwarf is the dense, collapsed core of a dead star. It is roughly the size of Earth, but contains about 1.4 times the mass of our entire Sun. That is mind-blowing density. A teaspoon of white dwarf material would weigh about 15 tons on Earth. The red giant is a massive bloated star near the end of its life. It is shedding its outer layers, constantly bleeding gas and material into space. And here is where things get interesting. The white dwarf is stealing that material. The white dwarf's intense gravity pulls hydrogen gas from the red giant onto its own surface. This stolen material accumulates, building up in a layer on the white dwarf's surface. As more and more hydrogen piles up, the pressure and temperature at the bottom of this layer increase dramatically. Eventually, the conditions become so extreme that the hydrogen ignites in a massive thermonuclear explosion. This is not like the slow, steady fusion happening inside normal stars. This is instantaneous, violent, and spectacular. The entire surface of the white dwarf explodes all at once in what scientists call a nova. But here's the crucial difference between a nova and a supernova. The white dwarf survives. After the explosion, the star settles down and begins stealing material from its companion again. The cycle repeats. For T Coronae Borealis, this cycle takes approximately 80 years. The last eruption occurred in February 1946, when a 15-year-old schoolboy named Michael Woodman from Wales observed the flare-up. He wrote to the Astronomer Royal about his observation, leading to the theory that the star flares every 80 years. Before that, it erupted in 1866. There are even historical records suggesting it may have exploded in 1217 and 1787. When the Blaze Star finally explodes, and trust me, it will, the show will be absolutely incredible. Currently, T Coronae Borealis, shines at magnitude +10. That is so faint, you need a decent telescope just to see it at all. But when the nova occurs, the star will suddenly brighten to magnitude +2. That is roughly as bright as Polaris, the North Star. Think about that for a second. A star that is currently invisible to the naked eye will suddenly become one of the brightest objects in the night sky. It will look like a brand new star has appeared in the heavens, which is exactly why ancient astronomers called these events nova, the Latin word for new. The explosion itself will be brief, but spectacular. The star will brighten dramatically over just a few hours, reaching peak brightness within about a day. It will remain visible to the naked eye for several days, possibly up to a week. Through binoculars or a small telescope, you will be able to see it for even longer, perhaps 2 weeks or more. What makes this especially exciting is that T Coronae Borealis is located in an easily recognizable constellation. Corona Borealis, the Northern Crown, appears as a small semicircle or backward C-shape in the sky. It sits between two of the brightest stars in the Northern Hemisphere, Arcturus and Vega. To find it, look for the constellation Hercules, which appears as a rough square of stars. Corona Borealis is just to the west of Hercules. The brightest star in the constellation is Alphecca, also known as Gemma, which normally shines alone at about magnitude +2. When the nova occurs, T Coronae Borealis will appear right next to Alphecca, creating a stunning pair of similarly bright stars, where there was only one before. Recent observations in early 2026 have astronomers on high alert. Scientists using the Alfred Jentsch telescope in Germany detected an increase in the strength of several spectral lines, indicating that the white dwarf is accreting matter at an increased rate. This is exactly the state that should precede the explosion. Now let us talk about the star that everyone cannot wait to see explode, Betelgeuse. Betelgeuse is the massive red supergiant that forms the left shoulder of Orion the Hunter. It is one of the brightest stars in our night sky and one of the most famous, and it is absolutely enormous. If you placed Betelgeuse at the center of our solar system, its surface would extend beyond the orbit of Mars, possibly even reaching Jupiter. This star is approximately 1,400 times larger than our Sun and 20 times more massive. It shines with the light of about 100,000 suns. And here is the kicker. It is dying. Betelgeuse is a red supergiant, which means it is already burned through most of its nuclear fuel. It is in the final stages of stellar evolution. At some point, probably within the next 100,000 years, but possibly as soon as tomorrow, it will explode as a supernova. When Betelgeuse goes supernova, it will be the astronomical event of human history. Located only about 500 to 700 light years away, it will become as bright as the full moon, possibly brighter. You will be able to see it during the day. You will be able to read a book at midnight by its light. It will dominate the night sky for weeks, possibly months. But here is the fascinating twist. In July 2025, astronomers made a groundbreaking discovery. They finally confirmed that Betelgeuse has a companion star. For nearly a century, scientists suspected that Betelgeuse might be orbited by a smaller stellar companion. Their hypothesis was confirmed when NASA researchers using the Gemini North Telescope picked out this companion star for the first time. The companion, which has been officially named Siwarha, is about 1.6 times the mass of our Sun. Siwarha orbits Betelgeuse at a distance of about 4 astronomical units. To put that in perspective in our solar system, that would be roughly the orbit of Jupiter. The orbital period is approximately 5.7 to 6 years. This discovery changes everything about our understanding of Betelgeuse's behavior. Remember that great dimming event in late 2019 and early 2020 when Betelgeuse suddenly dropped to about 40% of its usual brightness? Everyone thought the supernova was imminent. it turned out to be caused by a massive cloud of dust ejected by the star. But the periodic brightening and dimming that Betelgeuse exhibits? That is likely influenced by Siwarha. As the companion star orbits through Betelgeuse's extended atmosphere, it creates disturbances, a wake of sorts, that affects the light we see. Most importantly, this companion star discovery suggests that Betelgeuse might be younger than previously thought. If it is younger, that means it is farther from its supernova endpoint. So while Betelgeuse will definitely explode someday, that day might be farther off than we hoped. When Betelgeuse does finally go supernova, Siwarha will likely be completely destroyed, consumed in the blast. For now, though, this tiny companion continues its lonely orbit around one of the most massive stars in our galaxy, waiting for the inevitable. If Betelgeuse is impressive, then T Coronae is absolutely mind-blowing. Located about 7,500 light-years away in the southern constellation, Carina Eta Carina is one of the most massive and most luminous stars in the entire Milky Way galaxy. It shines with the power of approximately 5 million suns. Let me say that again, 5 million suns. The system actually contains 2 stars. The primary is a luminous blue variable weighing approximately 100 to 120 solar masses. The companion is also massive at about 30 to 80 solar masses. Together, they form one of the most extreme stellar systems known to exist. What makes Eta Carinae so famous is not just its size, but its history. In 1843, this star put on one of the most spectacular shows in astronomical history. Between 1837 and 1843, Eta Carinae underwent what astronomers call the Great Eruption. The star brightened dramatically, becoming the second brightest star in the entire sky, outshone only by Sirius. But unlike Sirius, which is only 8.6 light-years away, Eta Carinae was achieving this brightness from a distance of 7,500 light-years. During this eruption, Eta Carinae expelled approximately 2 to 3 solar masses of material. That means it threw off 2 to 3 times the mass of our entire sun in just a few years. This material was ejected at speeds of about 700 kilometers per second, forming the distinctive homunculus nebula that surrounds the star today. The homunculus nebula, named because it resembles a tiny human figure, consists of 2 massive lobes of gas and dust. Each lobe expands at a rate of about 1.5 million miles per hour and spans roughly 4 trillion miles. The entire structure glows from starlight, reflected off the dust particles within. Here is what makes Eta Carinae terrifying and fascinating in equal measure. Nobody knows what caused the Great Eruption. It was not a supernova because the star survived. Scientists call these events supernova imposters because they produce almost as much visible light as a real supernova, but the star does not die. Eta Carinae is expected to end its life in a true supernova explosion sometime in the astronomically near future. That could mean next year, or it could mean 1 million years from now. When it does explode, it will be spectacular. At 7,500 light-years away, it should still be visible in broad daylight from Earth, possibly rivaling the full moon in brightness. And here is the really wild part. When Eta Carinae goes supernova, it will likely produce a gamma-ray burst. These are the most energetic events in the universe, short of the Big Bang itself. Beams of intense radiation shoot out from the poles of the dying star at nearly the speed of light. Fortunately, the rotational axis of Eta Carinae does not point toward Earth. We will get to watch an incredible light show without being fried by gamma rays. But somewhere out there in the direction of Eta Carinae's poles, any planets or civilizations unfortunate enough to be in the way will be sterilized. Now let me tell you about a star system that might actually explode sooner than any of the others, V Sagittae. V Sagittae is a binary system located about 10,000 light-years away. Like T Coronae Borealis, it consists of a white dwarf and a companion star. But there is something very different and very alarming about this system. The white dwarf in V Sagittae is not just stealing material from its companion, it is devouring it at an unprecedented rate. The transfer of mass from the companion to the white dwarf is happening so fast that the white dwarf cannot handle all the material. This creates a massive halo of glowing gas surrounding both stars. In September 2025, astronomers using the Very Large Telescope discovered something shocking about this system. The white dwarf is gaining mass so rapidly that it is lurching toward the Chandrasekhar limit. The Chandrasekhar limit is the maximum mass a white dwarf can have, approximately 1.4 solar masses. Once a white dwarf exceeds this limit, it cannot support itself against its own gravity anymore. The result? Catastrophic collapse followed by a Type Ia supernova. Type Ia supernova are special. They are used as standard candles to measure cosmic distances because they all have roughly the same peak brightness. But they are also incredibly violent, completely destroying the white dwarf star in a thermonuclear explosion. What makes V Sagittae so interesting is that astronomers think this explosion could happen very soon, possibly within the next few decades or centuries. One prediction suggests that the white dwarf will produce a nova outburst in the coming years, during which V Sagittae would become visible with the naked eye. But eventually, probably within the next few thousand years, the two stars will completely merge in a catastrophic collision. When that happens, the resulting supernova explosion will be so bright it will be visible from Earth even in the daytime. Pablo Rodriguez Gil from Spain's Instituto de Astrofísica de Canarias explained that the matter accumulating on the white dwarf is likely to produce a nova outburst in the coming years. But when the two stars finally smash into each other and explode, this would be a supernova explosion so bright it will be visible from Earth even in the daytime. The speed at which this doomed stellar system is lurching wildly, likely due to the extreme brightness, is described as a frantic sign of its imminent violent end. So with all these stars preparing to explode, how can you actually watch when it happens? For T Coronae Borealis, the blaze star here is your game plan. First, download a stargazing app like Star Walk 2 or Sky Tonight. These apps will show you exactly where Coronae Borealis is located in your sky at any given time. Enable push notifications because the moment the nova is confirmed, these apps will alert you. Second, learn to find the constellation. Look for Arcturus and Vega, two of the brightest stars in the northern hemisphere. Draw an imaginary line between them. About 1/3 of the way from Arcturus to Vega, and slightly below that line, you will find Coronae Borealis. It looks like a small semicircle or backward sea of stars. Third, when you get the alert that the nova has started, do not panic. You will have several days to see it with the naked eye. The star will brighten over a few hours, but will remain visible for about a week. Through binoculars, you will be able to see it for even longer. Fourth, tell everyone you know. This is a once-in-a-lifetime event. The last person to see this was a 15-year-old boy in 1946. The next eruption will not happen until around 2126. Make sure you and your friends and family do not miss it. For Betelgeuse, you have it easier because it is already one of the brightest stars in the sky. Just look for the constellation Orion the Hunter. Betelgeuse is the reddish star marking Orion's left shoulder. If it suddenly becomes as bright as the full moon, trust me, you will notice. For Eta Carinae, you need to be in the southern hemisphere, or at least at a low northern latitude. The star is located in the constellation Carina the Keel, which is part of the old constellation Argo Navis, the ship of Jason and the Argonauts. It is currently visible as a 6th magnitude star, which means you can see it with the naked eye on a very dark night, but barely. The exciting thing about all these potential explosions is that modern technology means we will not miss them. Professional observatories monitor these stars constantly. Amateur astronomers around the world watch them every clear night. The moment something happens, the news will spread across social media within minutes. And when the explosion happens, it will not just be a light show. Modern telescopes will capture every detail of the event. The James Webb Space Telescope will observe in infrared. Hubble will provide optical images. X-ray telescopes, like Chandra, will study the high-energy emissions. Radio telescopes will track the expanding shock waves. We will learn more about stellar evolution in a few weeks than we have learned in decades of theoretical work. We will see in real time how heavy elements are forged and scattered across the universe. We will witness the birth of a neutron star or black hole. We will gather data that will inform our understanding of the cosmos for generations. So here is where we stand in early 2026. T Coronae Borealis. The blaze star could explode literally any day now. It has been following the exact same pattern it showed before its last eruption in 1946. When it goes, it will create a new naked eye star in Coronae Borealis, shining as bright as the North Star for about a week. Betelgeuse has a companion star named Siwarha, which changes our predictions about when it will go supernova. While it might still explode tomorrow, the discovery suggests it could be younger than we thought, meaning the explosion might be farther off. When it does happen, it will be as bright as the full moon, visible even during the day. T Coronae is one of the most massive stars in the galaxy and one of the closest supernova candidates to Earth. It already had one massive eruption in the 1840s that made it the second brightest star in the sky. When it finally goes supernova for real, it will be visible in broad daylight. V Sagittae is a cannibal system where a white dwarf is devouring its companion so fast that it might trigger a supernova within the next few decades to centuries. When these stars collide, the explosion will be visible from Earth in the daytime. What strikes me most about all of this is how privileged we are to live in this moment. For most of human history, people looked up at the stars and saw them as eternal and unchanging. The heavens were the realm of the gods, fixed and perfect. But we know better. We know that stars are born live and die. We know that some of them die in the most violent explosions the universe can produce. And we are living in a time when we might actually get to witness one of these explosions up close. The last nearby supernova visible to the naked eye was in 1604. That is over 400 years ago. Johannes Kepler observed it, and it helped establish him as one of the founders of modern astronomy. Before that, there was Tycho's supernova in 1572. Before that, the Crab Nebula supernova in 1054. We are overdue. Statistically speaking, our galaxy should produce a supernova every 50 to 100 years. We have not had a close one in over 4 centuries. The odds are in our favor that we might finally get to see one in our lifetimes. And when it happens, we will all become part of history. We will join the ranks of those lucky humans across the millennia who looked up and saw something that no one had ever seen before. We will witness the universe in its full, terrible, beautiful, violent glory. If you found this video fascinating, make sure to hit that like button and subscribe. I will be tracking all these stars, and the moment one of them explodes, I will make a video about it. Drop a comment below. Which star do you think will explode first? Are you rooting for the blaze star, the dramatic Betelgeuse, or the monster T Coronae? Or do you think V Sagittae will surprise us all? For those of you who want to start watching the sky yourself, I have put together a resource guide in the description. It includes links to stargazing apps, information about how to find these stars, and resources for keeping up with the latest astronomical news. Remember, the universe is not a static museum. It is a dynamic, violent, spectacular arena of creation and destruction. Stars are exploding right now across the cosmos. We just happen to have a few nearby ones that are about to put on shows for us. The Blaze star could go tonight. It could go tomorrow. It could wait another year. But it is coming. And when it does, I will see you back here to talk about what we observed and what it means for our understanding of the universe. Until then, keep looking up. Because somewhere out there, a star is preparing to die, and we get to watch. Thanks for watching, and I will see you in the next one.